Today we will be learning about Excel Solver. Excel Solver can be used to solve linear programs when the number of constraints becomes computationally hard. So it is an alternative solution to graphical method and the simplex algorithm. In order to use Excel Solver, we must first make sure that in Excel, we can go to the add-ins. Make sure that the checkbox for the solver is checked. This means that the solver add-in is enabled for Excel. So going back to the Excel Solver algorithm, we go to an example LP. So this was previously discussed. The LP maximize z equals 3x1 plus x2, subject to 2x1 plus x2 is less than or equal to 8, 4x1 plus x2 less than or equal to 12, and x1 and x2 are both greater than or equal to 0. So how do we solve this using Excel Solver? The first step would be to translate all these coefficients into a table format in Excel. We do that by making a table. So one row for the objective function, one row each for each constraint, then for each decision variable, we have a last row. Now we use one column to represent each decision variable. In this case, we have one column for x1 and one column for x2. We have one column for formulas, and finally, we have an operations column and right-hand side column. So we translate the coefficients directly. This cell would be 3, since we are obtaining the coefficient from the objective function value of x1. This cell would be 1, again, just the coefficient of the x2 in the objective function value. So we move on to the constraints. This will be 2 and 1, 4 and 1, and finally, the right-hand side. We leave the right-hand side of the objective function, and we translate the right-hand side values from the original LP, original LP constraints 8 and 12. We then copy the operation, whether it's less than or equal to or greater than or equal to. So in this case, both are less than or equal to constraints. So we copy here the less than or equal to symbol. So what needs to be done next is we need to express the objective function value represented by this cell as a function of the existing cells to be used. So this cell can be expressed as the sum product of this row and the decision variable row. That is also true for the two remaining cells. So it's also the sum product of their corresponding rows for x1 and x2 and the decision variable rows. And finally, we do that for the last constraint. This. So with that, we are ready to start our Excel Solver solution. So we need to go to Data, the Data tab, then the Solver option. Once we are here, we specify the cell which represents the objective function value z. In this case, that is this cell I4. So from here, we go to the next option. This is a maximization problem. So this is correct. Then we solve this by changing the variable cells represented by G7 and H7 in this example. So we just highlight G7 and H7. This text box represents the addition of the constraints. So we add one constraint by referencing the formula of constraint 1. So the constraint is less than or equal to, which is consistent with our model. And this is the right-hand side, so we just need to highlight the right-hand side of the constraint, of the corresponding constraint. So we add the first constraint, then we do the same for the next constraint. So formula for constraint 2, less than or equal to the right-hand side for constraint 2. Once we are done, we press OK. We check this checkbox to make sure that we implement non-negativity constraints. And finally, we select the option Simplex LP. This makes sure that Excel performs automatically the simplex algorithm. So once we are done, we just click OK to keep the solver solution. Then these values in the highlighted cells would represent our optimal solution. So we could see that the optimal solution to this LP is x1 equals 2, x2 equals 4, and the objective function value would be 10. This would yield the optimal solution for our given LP. So solving another example, we can do the same for this example. So given this LP, we are to solve using the Excel solver. So again, I just translate the coefficients, 700 for x1 and 1400 for x2 in the objective function. For the first constraint, x1 coefficient is 12 and x2 coefficient is 20. Second constraint has 60 for x1's coefficient and 160 for x2's coefficient. Then the right hand side are 78 and 480 respectively. So the operations, again, I insert symbols that represent the type of inequality. So both are less than or equal to inequalities. And finally, I express the formula cells as the sum product of the coefficients and the cells representing the decision variables. So I do this for all the objective functions and constraints. And for the last constraint, this one. So now we are ready to perform the Excel solver. So we just specify the objective function value. So again, this is H4 in this case. You want to maximize the value of H4 by changing variable cells. So we need to highlight these two cells that we need to alter. Then the constraints are, so first we add the first constraint. Constraint 1 less than or equal to the right hand side 78. Then we add the second constraint, the formula cell less than or equal to the right hand side, in this case 480. Again, so make sure to check this checkbox to simulate the non-negativity constraints, and then finally highlight simplex LP. So solving this LP, so the optimal solution is x1 equals 4, x2 equals 1.5, and the optimal objective function value is 4,900. Now you know how to solve linear programs using Excel solver.